this chapter, we're going to be looking at radicals. In this lesson, we're going to be looking at dividing and rationalizing radicals.
Okay, everybody, so now we're going to take a look at dividing radicals. We've looked at multiplying, now we're going to look at dividing. And you're going to see that for the first little bit here or so, dividing is very, very similar to multiplying. So you can divide radicals as long as the index is the same. And then what we do here is we divide the coefficients and then we divide the radicands just exactly the way we did multiplication. And then afterwards you got to simplify, okay? So we're going to take a look at some examples in just a second here just to illustrate that. But it boils down to something like this. If you've got a root b and you're dividing it by c root d, then this becomes a over c multiplied by the square root of b over d. And what we're really hoping for is that this can simplify down. Okay, so that's basically the mechanism of it. Now that's not it. Okay, that's not the total story here, but we're going to go through some examples first, and then we'll come back and I'll tell you the rest of the story in a bit. Okay, so for the questions here, it says divide and simplify each of the following. Okay, so this is going to become the square root of 70 over 7. And then I just divide, 70 divided by 7 is 10, and so this reduces down to the square root of 10. And I can't do anything else with the square root of 10. I can't simplify it any further, so I'm done. Over here, this next one, this becomes 30 over 15 multiplied by the square root of 6 over 2. Then I do the coefficients, 30 divided by 15, that's easy, that's 2. And 6 divided by 2 is 3. Okay, now let's take a look at this one. So what we can do here, again, is the coefficients, so it'll be negative 25 over 5, and then this will be root 40 over 5. Well, negative 25 over 5, that's easy, it's going to be negative 5. And 40 over 5 is 8. Okay, but we know that 8 is 4 times 2. So this is going to be root 4 times root 2. So the square root of 4 is 2, multiplied by negative 5, so it'll be negative 10 root 2. So there's a little bit more involved with that particular question than some of the other ones. With this one right here, again, we're going to split that up, so it's going to be 45 over 9, and this is going to be 32 over 2 inside the radical. 45 over 9 is 5. And then 32 divided by 2 is 16, but don't run away from that yet, because you know that the square root of 16 is 4, and so 5 times 4 will equal 20. That worked out quite nicely. I like that one. Now here we run into the issue here that we need these things to be positive. And either way here, when we cancel the b's, okay, because when we put this all under one radical, we're going to cancel the b's. This is going to be equal to root a. That is true so long as b is greater than 0. I can't let b be equal to 0. Okay, in both cases, I can't let b be equal to 0. And here, I know that a must also be greater than 0. Actually, a can be greater than or equal to 0, but b has to be greater than 0. If I can't let b be equal to 0 because I'm dividing by the b down here. And now finally over here, again, to split that up, we're going to have 10 over 20. Now, notice that the larger value is in the denominator, so I know I'm going to get a fraction there. And then 24 over 2 in the radical. And so this will be 1 over 2. Square root of 24 divided by 2 is 12. Okay, well, we know that 12 can be written as 4 times 3. So now I'm going to speed things up a little bit here. I know that the square root of 4 is 2, and I'm going to bring that out. Well, half of 2 is 1. Which means those kind of go away, those cancel, and I'm left with just the square root of 3. Okay, and there you go. Okay, now we're going to keep on going and do some new questions here. But notice this little note here. It says if you're able, simplify the radical before you divide, because it makes the calculation easier, and that is true here. So let's take a look at some more questions here where that's probably going to apply. So for example, 2 root 27 over root 12. I know that root 27 can be written as 9 times 3. And I also know that root 12 can be written as 4 times 3. So this is going to end up being, I can take the square root of 9 and pull that that out there. So that's going to pull out a 3. So 2 times 3 is going to be 6 root 3. And then down in the denominator, I know that that root 4 is going to become a 2. So it'll be 2 root 3, and I'll leave that inside there. Now, I hope that makes sense. I know I'm skipping some steps that I used to do, but I'm hoping that we can kind of push you through this a little bit quicker now after the repetition, because you know that what I'm going to do is split this up into 2 terms and then pull out the perfect square. Split this up into 2 terms, pull out the perfect square. The root 3's are going to cancel. Root 3 over root 3 is 1, and then 6 over 2 is 3. Okay, and there's our final answer. Over here, okay, so 4 root. Okay, now we got to think, what's the highest perfect square that's a factor of 54? Well, I mean, I know 9 is a factor of 54. And actually, I think 9 is the best I can do there. That's going to be 9 times 6. And down here, well, okay, 8. We've done 8 a bunch of times before. That's already, we know it's going to be 4 and 2. So in the numerator, I know that I'm going to pull out the square root of 9. The square root of 9 is going to be 3, so it's going to leave me with 12, because of the 4 there, with a root 6. Okay, the square root of 4 is a 2. I pull that out. There's a 3 there, so together that's going to be 6. And so that's going to be 6 root 2. Okay. 12 divided by 6 is going to be 2. And then I've got this root 6 over root 2. Now remember, that sits like this. It's going to be root 6 over 2. Just jump below the page number here. So that's going to end up being 2 root 3. Okay. Now over here. Okay, well now this one is going to take a little bit of fiddling. Off the top of my head, I don't know 126, how that simplifies here. Now I'm going to divide by a couple things. I'm going to divide by 16, 126 divided by 4, nope. 126 divided by, let's say, 9. Okay, 126 divided by 9 is 14, so that's probably the largest perfect square I'm going to get, because 14 is 2 times 7, and 9 has got the 2 3s. So, yeah, that's going to be the largest perfect square. 112, well, let's divide that by 112 divided by 9. Well, that doesn't work. Let's divide that by 3, see what we get here. No. 112 divided by 4. 112 divided by 16. I think I can do better. So 112. Now I was just doing that off on the side of my calculator here, and I'm just trying perfect squares, and I get 16 times 7. So in the numerator, I know that the square root of 9 is going to be 3, and I'm multiplying that through, so it's going to be 8 times 3 times the square root of 14. The square root of 16 is 4 times the square root of 7. And so this is going to end up being 24 root 14 over 4 root 7. Well, now you know that we split this up, 24 over 4, and this will be the square root of 14 over 7. Well, 24 divided by 4 is 6, 14 divided by 7 is 2, so this becomes 6 multiplied by the square root of 2. All right, everybody, so for this question, it says divide each term in the numerator by the denominator and simplify. Okay, now something you got to know about this, because it seems to be a thing in algebra here, a rule in algebra that a lot of people tend to forget. If you've got a plus b divided by c, that is the same as a over c plus b over c. Like when you're adding fractions together, if the denominators are the same, basically we write the sum all over that shared denominator. Okay, so all I'm basically asking you to do is to go backwards to that and just distribute that denominator to both of those terms in the numerator. You can do that. Now the mistake that people make is when they frequently, you'll see people do this, right? Where you'll have a plus b, and this will be divided by a, and then they'll just cancel the a's. Well, no, that should be a divided by a plus b divided by a, in which case those two a's cancel. But you're still left with that b divided by a. You can't get rid of that denominator with an a in it. So you got to make sure that you're doing that correctly. So here, what we want to do is basically exactly that. I want this to be root 20 over root 5 plus root 40 over root 5 minus root 90 over root 5. And now, Okay, we make these, we put the two radicals together as one radical. Whoops, oh shoot. As one radical. Ah, that looks terrible. Let me try that again. Okay, that's going to be root 90 over 5. And so now root 20 over 5, that's just simply going to be the square root of 4. 40 over 5 is the square root of 8. And then 90 over 5 is going to be the square root of 18. And now we simplify. Okay, well, the square root of 4 is easy. That's just going to be 2. But this is, 8 is 4 times 2. And 19, sorry, 19. I'm anticipating the number I'm going to write here. 18 is 9 times 2. And so this will end up being 2 plus 2 root 2 minus 3 root 2. Now, I still have one more step of simplifying here because I've got two terms that are like terms because of the radicals. And so this will end up being 2, that's this one up front here, minus, well, 2 root 2's minus 3 root 2's is going to be a negative root 2. So 2 minus root 2. Now we want to do the same thing here. This is going to equal 3 root 18 over root 2 plus root 2 over root 2. See, now here the mistake that a lot of people would make when they look at this is they would be tempted to just cancel those root 2's. But you can't if that's all you're doing. As long as you're doing that together with the rest of this operation, that's fine. So now this becomes this 3 times the square root of 18 over 2. Well, okay, who am I kidding? Root 2 divided by root 2 is 1. Okay, it just is. Minus 12 divided by, the square root of 12 divided by 2. So this is going to be 3 root 9 plus 1 minus the square root of 6. Well, the square root of 9 is 3, multiplied by 3 is 9, plus 1 minus, well, root 6 is about as nice as that's going to get. So when I put together the two constant terms here, 9 plus 1, I get 10 minus root 6, and I'm done. Okay. Now for that second part that I was telling you guys about here, we're going to take a look at rationalizing the denominator. Okay, so if the top of the radical is not divisible by the bottom, then we got to multiply the top and the bottom by the radical in the denominator to write an equivalent expression that contains no radicals in the denominator. Okay, that's a whole bunch of blah, blah, blah. Just to give you the idea here, if I had, for example, let's say root 2, and I divided that into 3. Well, okay, that you can make sense of that. You can see what's going on there. I can take, for example, on a number line here, here's 0. I actually can identify, the root 2, here's 2, and then the root 2 somewhere here, and I can figure out what it means to divide that into 3 equal pieces. But if I flip that and make that 3 divided by root 2, well, conceptually, that's a little bit different here. I mean, here's 0, 1, 2, 3, and so I've got this line segment that's 3 long. How do I divide that into root 2 pieces when, honestly, I can't even identify what exactly root 2 is? Now, I know you're going to go to your calculator, press root 2, and say, here's what it is. But even that's an approximation. Okay, root 2 is this infinite non-repeating decimal. So conceptually, there's a little bit of a gap here. I don't know what that means here. So what we have done is we have this operation where what we do, when we have a radical in the denominator, I'm going to multiply numerator and denominator by that same radical. Now bear in mind, when I multiply by root b over root b, I'm multiplying by 1. Multiplying by 1 doesn't do anything. So this is going to end up being, when I multiply root a times root b, I get root ab, but the denominator simply becomes b. And that's what we're shooting for here. Okay, so this is what we mean by rationalizing. We're going to take the denominator that's got an irrational in it, and by multiplying by that square root, we're going to create a rational down in the denominator. Okay, now let's take a look at some questions here where we're being asked to rationalize. So I see this root 5 down here, so I want to get rid of it, so I'm going to multiply numerator and denominator by root 5. And in this case here, root 5 times 1 is root 5, and then root 5 times root 5 is simply going to be 5. Okay, easy. Here, because I can't simplify that any further, I'm going to multiply numerator and denominator by root 7. And so this is going to get me root 21, oh boy, that's not 21. That was weird. Root 21 over, and root 7 times root 7 is simply going to be 7. Okay, next. Now here, before I do the rationalizing, I might want to simplify that a little bit. I notice that my coefficients do simplify. 8 divided by 2 is 4. But I'm still stuck with that root 3 in the denominator, and I multiply numerator and denominator by root 3. And so what I'm left with here is going to be 4 root 15, because of the root 5 times the root 3, and root 3 times root 3 is 3. There's really nothing else I can do to simplify that. Now here, I'm going to try simplifying this first. Now I've got this root 2, and I know that this root 10 here can be rewritten as root 5 times root 2. Now I'm choosing to do it this way here. I know that I can split that up. This is basically just me going in reverse of multiplication, right? If you're to multiply root 5 by root 2, you'd get root 10, which means root 10 is the same as root 5 times root 2. Now, 2 over 4 is going to be 1/2. The root 2's here cancel, and so I'm left with 1 and a root 5 in the denominator. Now I'll multiply numerator and denominator by root 5, and this will give me a root 5 in the numerator. I've got root 5 times root 5 in the denominator, which will be 5, but there's still a 2 down there, so this ends up being root 5 over 10. Over here, okay, first of all, I'm going to split this up into root 18 over root 5. And before I rationalize, I'm going to turn that root 18 into, I'm going to turn it into 9. 9 times 2, root 5. And so the numerator becomes 3 root 2 when I pull the square root of 9 out. And now multiply numerator and denominator by root 5. So in the numerator, root 5 times root 2 will be root 10, and then the root 5 times root 5 in the denominator is just 5. With this one right here, I've got root 3 over, well, let's simplify the root 12 here. So that's going to be 4 times 3. And then the square root of 4 is 2. I can take that out, and I'm left with a root 3 there. And actually, this is wonderful. Those just cancel. And so you're left with 1 over 2. And that's it. Okay, now for these questions here, it says express each numerator and denominator in simplest form and then rationalize. Okay. Well, root 500 is going to be the same as root 100 times 5, and root 27 is going to be 9 times 3. And I'm just trying to pull out the largest perfect square that I can. The square root of 100 is 10, but that still leaves me with the square root of 5 left over that I can't simplify. The square root of 9 is 3, but that still leaves me with a root 3 that I can't get rid of. And now, to rationalize the denominator, I'm going to multiply numerator and denominator here by root 3. So this is going to give me 10 root 15 over, now, the 2 root 3's multiplied together will give me another 3. Multiplied by that 3 gives me 9. So 10 root 15 over 9. And now here, with 240 here, I got to think here, what's the largest perfect square that I can divide that by? I'm thinking 16. Because if I do that, I'm going to get 16, I believe that's times 15. And then with 108, actually 108, I'm trying to think here, what would that be if I divided that by, no, 108. It's 9 times 12, so, 36. Yeah, sorry, I can make that the square root. I can take 36 out there. And so then this becomes, well, the square root of 16 is 4, times that 3 is going to be 12 root 15. Square root of 36 is 6, and I've got that root 3 there. Well, actually, this is going to be beautiful, because this will be 12 over 6, and this will be root 15 over 3. In this case, everything works out beautifully. 2 root 5. Didn't even need to rationalize that one. Okay, in this last question here, we're going to do this in 2 different ways. First of all, we're going to simplify the radical expression by rationalizing first, okay? And then I'll do it by dividing each term in the numerator by the denominator. First thing we're going to do, though, is we're going to simplify, though. So this is going to end up being, the square root of 10 is going to be, sorry, the square root of 100 is going to be 10. And then I know that 28 is 4 times 7 over root 2. So I know that this is going to be 10 minus 2 root 7 over root 2. That's where I kind of want to start this one. So to start by rationalizing, I'm going to have 10 minus 2 root 7 over root 2. And now I'm going to multiply root 2, root 2. Okay, so this will be 10 root 2. I'm going to distribute the root 2 to both terms, minus 2 root 14 all over 2. And now I've got a common factor of 2 in the numerator, and I'm doing this because I see a 2 in the denominator, so it's going to give me 5 root 2 minus root 14 all over 2. The 2's will cancel. I'm left with 5 root 2 minus root 14. So that's my goal here. I'm hoping that I get that with my next one. So now, here, it says dividing each term in the numerator by the denominator, so I've got 10 minus 2 root 7 over root 2. And I'll make this 10 over root 2 minus 2 root 7 over root 2. Oops, can't see that. And now I'm going to rationalize in both cases. So in both cases, I'm going to multiply by root 2 over root 2, root 2 over root 2. Now it's gotten messy here. Bear in mind there's still a subtraction there. So this will become 10 root 2 over 2 minus 2 root 14 over 2. But now the division is quite clear. 10 divided by 2 is 5 root 2. And then the 2's will cancel, and I'm just left with root 14. And there it is. It's the same thing regardless of how I approach it. And really, it's not even all that different in terms of the amount of work that you've got to do.